Hi, I'm Ms. Hall, and this is Lesson 21, Quadratic Formula and Modeling. In our previous lesson, we learned how to solve quadratic equations by using completing the square. And now we're going to learn another method to solving quadratic equations, and that is using the quadratic formula. The quadratic formula: let a, b, and c be real numbers such that a is not equal to 0. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are, and this is the quadratic formula. Now you will not, on the regions, this will be part of the reference sheet, so you won't have to memorize it. But on every other standardized exam I remember taking, I was responsible for memorizing it. So it's probably best that you just memorize it. For myself, I had a student teacher that taught me a song to memorize this, which you will hear me sing as I do these problems, which is to Pop Goes the Weasel. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. And so this is the formula we're going to be using to solve the quadratic equations we have in today's lesson. Keep in mind, starting with example 1, that the equation must be in standard form before we apply the quadratic formula. So example 1, we have to move that constant of 5 over, so that we have x squared plus 3x minus 5 equals 0. And now we can identify a, b, and c because it's in standard form. A equals 1, b equals 3, c equals negative 5. Now we'll insert these values into the quadratic formula. And I'm going to sing the song aloud. That's really what goes on in my head as I fill this in. I have x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I've set it up, and now I'll work on simplifying. X equals negative 3 plus or minus. I just put this expression in my calculator, and you get 29 all over 2. I cannot simplify the radical 29, so I could leave it as this. Let me think, is this an eraser here? No, kind of. I could leave it like this. That's fine, there's nothing more I can simplify about it. I could, if you prefer, make it into decimals. I could have put in my calculator as negative 3 plus the square root of 29 divided by 2, and the same thing with minus. And you will get that x is approximately 1.19 and x is approximately negative 4.19. So if you want it in decimal form, I'm fine with either. What you should know is when we're solving quadratic equations, one option is to get 2 real solutions like we did in this case. If I were to sketch this parabola, look something like this, and it would have 2 x-intercepts. Those are the 2 real solutions. Example 2, solving an equation with 1 real solution. Solve using the quadratic formula. Okay, well, we'll begin by getting it in standard form. I'll move everything to the left side, so I have 25x squared minus 20x plus 4 equals 0. Now that it's in standard form, I can identify the a is 25, b is negative 20, c equals 4, and plug it into the quadratic formula. X equals negative b, so now we got positive 20, negative 20. Negative b plus or minus square root b squared minus 4ac all over 2a. Plugged it in. Now I'll simplify. X equals 20 plus or minus the square root. And I put this in my calculator with the parentheses exactly where they are. And I got 0 over 50. Square root of 0 is 0, and 20 plus or minus 0 is going to be 20. So this is really 20 over 50, which can be reduced to 2/5. Okay, so there's only one solution, right? Because that radical was the square root of 0, and adding or subtracting 0 doesn't change the numerator. And one real solution means if I were to sketch this parabola, it has one x-intercept. To say more specifically, it's just the vertex of this parabola is the solution here, because that's the only point that has the x-intercept. It only touches once, so it must be the vertex. Example 3, solving an equation with imaginary solutions. So we already know there's going to be an I in the solution. Solve using the quadratic formula. Same steps as before. First, get it in standard form. Get this equation in standard form. So we have negative x squared plus 4x minus 13 equals 0. Identify the a, b, and c. You really don't need to write this part. I'm just writing out all the thoughts that are happening in my head. Then put a, b, and c into the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And now simplify. Negative 4 plus or minus the square root of, put this in my calculator, and I got negative 36 all over negative 2. Okay, let's simplify this radical. Square root of negative 36 is really the square root of 36 times the square root of negative 1, which is really 6i. There's my imaginary part. Go back down here. I have negative 4 plus or minus 6i divided by negative 2. I can simplify this further. The negative 2 in the denominator means I'm dividing both terms by negative 2. So I could think of it as it's negative 4 divided by negative 2 plus or minus 6i divided by negative 2. And now I can simplify, and I have x equals 2 plus or minus, dividing by that negative 6i by negative 2, I get negative 3i. But I can just keep it as plus or minus 3i. One of them you're going to add, and one time you're going to subtract. And I can keep this as my solution here. Now, having no real solutions and 2 imaginary means the parabola never crosses the x-axis. If I were to sketch this parabola, it would look something like this. It never crosses, has no solutions, no real solutions, no real roots, just 2 imaginary solutions. Okay, start by getting it in standard form. X squared plus 8x plus 41 equals 0. A equals 1, B equals 8, C equals 41. Quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And now simplify. X equals negative 8 plus or minus, putting this in your calculator, negative 100 over 2. Simplified. Square root of negative 100 is the same as the square root of 100 times the square root of negative 1, which is 10i. So we have negative 8 plus or minus 10i all over 2. I can divide both terms by 2. And I get negative 4 plus or minus 5i. If I wanted to double check that this was a reasonable answer, I could graph this equation, right? Change this to y and make sure that the parabola has no x-intercepts.